In this video, we will solve a problem that requires the use of an interface that we have to create as part of our solution. I've chosen a problem from the end of the textbook chapter that revolves around this idea of a carbon footprint. I don't particularly know a lot about how carbon footprints are calculated, so I'll have to look that up. And I also am aware that the end of the problem statement at least, tells us to put objects into a list, and in this course we haven't covered lists yet, so I'm going to make a slight change there. I'm going to use an array instead. And the way these work is I always recommend that you pause the video and attempt to solve the problem yourself, then come back and press play and you can compare my solution to the way that you solve it, or at least attempt to solve it. And the other thing I like to point out is that I haven't solved this ahead of time and then recorded the video. I haven't looked at the problem until now, so I often make mistakes along the way and I don't edit them out so that you can kind of see the way that I troubleshoot as I'm working through it. So go ahead and pause and take a shot at the problem, then come back and play the rest of the video. I have created the project I'm going to use to solve this problem, and I've created my little comment block with some information there, and I'm ready to get started. So the first thing I'm going to start with is the interface, iCarbon footprint, and so I can make that a couple of different ways. If I just go right click, add new item, interface will be one of my choices. You can also do the same thing through the class diagram tool. And so this is the start of our interface, and an interface generally is pretty simple, or it can be pretty simple. It doesn't have to be a very complicated structure. I just want to indicate that any classes that are going to implement the iCarbon footprint interface need to have a getCarbonFootprint method. And the only significant decision I have to make about it at this point is what the return type will be. And so I did some basic research on carbon footprints. I didn't know much about them, but a carbon footprint is measured it's essentially a measurement or an estimation of your carbon dioxide output, right, or the carbon dioxide that you're putting out into the environment. So it could be any numeric type here for that. I'm going to use a double so that I can have some decimal data if necessary. I don't know how complicated these calculations will be. So get carbon footprint, and again, the key to an interface is that there's no code for the implementation here. I'm just defining what the rules are for classes that are going to implement this interface. So I don't have to write any code. I don't have to do any calculations for a carbon footprint. I'm just setting up that as a required method. So I'm done, I think, with my interface, and I can move on to some of my other classes. So the next class that I'll create is going to be bicycle, for the simple fact that a bicycle doesn't have any carbon footprint, so I know that one's going to be really easy. So I like to do the easy parts first. So this time I'm going to create an actual class. I'll call it bicycle. And if I want to make this implement that interface, I just add, just like any other kind of inheritance, and at this point the compiler is going to throw an error. It's going to produce an error because I haven't created that getCarbonFootprint method. So I've solved my initial error. I've created a new one because I've got to return something. If I'm going to say the return type is double, then I need to actually have a return statement. And again, I picked bicycle because a bicycle doesn't have a carbon footprint. It's human powered, right? So it's going to return 0.0. And that's it. I should acknowledge maybe that if I want to get very specific and detailed about this, the bicycle has a carbon footprint from when it was built, and the tires and things like that. At some point down the line, at some point earlier on in the process, there was carbon dioxide created. But the problem doesn't state that, so I'm going to keep it simple and say, well, if we're using a bike, we're not producing any new carbon dioxide. So I'm done with that that class that implements iCarbon footprint. I'm ready now to move on to my car and my building. Problem is, I don't know the formula that I'm going to need to do those calculations. So at this point, I'm going to pause the video and I'm going to go get on Google and look up these different formula and see what I come up with. After spending some time on Google, I found some sources that I will use to make my calculations, and I've set up just the documentation for my classes. I haven't actually written any code. But for a car, I found this site gave me the figure 18.07 pounds of carbon dioxide for every gallon of gasoline that we burn, and it gave sort of the chemistry reasoning for that. And I've used that to produce some test cases. And again, the idea of a test case is that we can put in some values into our program and see if we get the result that we should get. So I'm not doing anything fancy. I just use this little shorthand that is input, and then with a little arrow, output. So if I have a car that burns 15 gallons of gasoline, that should produce 271.05 pounds of carbon dioxide. I can put in 15 gallons and my code should produce that. And then I made up a couple other test cases here to try when I get my program working. For buildings, it turned out to be fairly complicated to calculate the carbon footprint of a building. There's all kinds of factors, and since the problem didn't say, and since I don't want to make a video that goes for 3 hours, I very much simplified, and I just said, well, I'm going to look at just electrical usage for a building. And so I went to the EIA website, and I found that even this, you'll see if you go to that site, there's a whole chart of different types of coal that you can burn and things like that. So I just picked one. I won't pretend there was anything more sophisticated about it. But I found that for every kilowatt hour of electricity that we consume burning this particular type of coal, we produce 2.07 pounds of carbon dioxide. And so I made up some test cases for that using that same shorthand format. This first number was on the same site. It's what the average U.S. residential building uses per month. The other ones I just made up, 5,000, and then just kind of a random number. So those are my test cases and my calculation that I'll use for a building. And again, I haven't written any code yet. At this point, we're ready to start implementing these classes. Now, if we look at my bicycle, my implementation, very straightforward. It just has this one method that is required by our interface, and it returns 0 because there's no calculation to be made. I'll do cars next on this. The additional complication now with these other types is that there needs to be more to our class, because a car has to have the number of gallons that it is consuming. So the first thing I need to do is, of course, implement that interface. So I'm going to implement iCarbon footprint. Okay. And as soon as I have done that, just like with the bicycle, I'm going to get an error saying, well, if you're going to implement iCarbon footprint, you have to write a method called getCarbonFootprint. So I'll go ahead and get that part of it out of the way. And of course my error now is that if I'm going to say it returns a double, I have to actually return a double, just like we did there. And the little recipe that I use, it's very much overkill for experienced programmers, but when I'm working with beginners, what I always say is, if you have a method that returns something, in this case a double, make a double. This is going to be carbon dioxide that it returns, right? So I'll just call this CO2. And I'll set it to, I like to use -1 as a default value. Then I'll skip a few lines and say return CO2. And now what that leaves me with is a little gap in here. I do my calculations here. For now the program will compile and I can build from here. Okay, so in order to calculate this, we need to know how much gasoline the car consumed. And there are several different ways to get that into that data, that number, into this class, into the object that's built from this class. The problem doesn't state how that should happen. Theoretically, we could have that passed in as like a parameter. In other words, get the carbon footprint based on this much gasoline usage. But I don't really want to mess with my method signature here. So what I'm going to do instead is say, well, I'm going to have just a field for that, and then I can have either a constructor or a setter or a property, whatever, to establish that. So I'm going to have a double gas usage, and I'll mark that as private. Okay, so that's going to be my field. And then what I'm going to do, just for the sake of simplicity, is just make a constructor that says, well, that's just going to take, when you create a car, you're going to have to tell us how much gas it used. Okay, so we've solved that problem. I now have a way of holding how much gas has been consumed and a way of getting that value into my object. And so now the last little bit of this is to do the math. And so again, this method is very much overkill for such a simple formula, but I'll stick with it for the sake of clarity, and I'll say, well, the CO2 equals gas usage times, and then my little constant up there is 18.07, and I'm using the word constant here deliberately, that if that's something I'm going to use often, I would consider maybe making a constant value for something like CO2 per gallon or something like that. But that should be the idea. I haven't tested this yet, but I think that that's going to be correct. And honestly, I usually will go and test my car now and make sure that's working before I worry about the building. So that's the way I'm going to do it in the video. So we'll go over to our main method. And actually, I'll test bicycle first. There were no test cases for that since it just returned 0 every time, but we should still verify that it's working. And it'll give us a chance to see how we can test this. So create a bicycle object with the default constructor. And I just want to output the return from my object's getCarbonFootprint method. And let's test that and see what we get. So far, so good. And I guess I can label that as the bicycle's footprint. And I'll want to do the same thing with my car. Now, with my car, I've said that in order to construct a car, I need to provide the amount of gas used. And so this is where my test cases come in. So my first test case was 15. So I'll put in 15.0. It is a double, so I should have the 0.0 on there. I'll copy and paste my handiwork here. And when I run this, hopefully I get 271.05. So far, so good. And now all I have to do is change that value to my other test cases, each one in turn, and just verify that it is calculating correctly. So 100.0. And 12.35. I could, of course, also just make additional car objects and assign each of my test cases that way. Either way is fine for now. Okay, so it looks good. It passes all of our test cases. And so the only class that's left is building. So let's go over and finish up building. It's going to work essentially the same way. I need to make sure that we are implementing that iCarbon footprint interface. And because of that, I now have to have a get carbon footprint method. And I'll ignore the error for now since I already know what I need. I'm going to need a variable to hold the kilowatt hours that were consumed or used. And I'll need a constructor to set that value. And this time I won't do the recipe. I'll show you the way most more experienced programmers might write this. Is I'll just do the calculation on the fly here. And I'll say return this dot kilowatt hours times our footprint rate. Oops, I grabbed the wrong one. And often if you do that, I like to put parentheses around it just for clarity and readability and to make sure people looking at it can see that I'm returning a calculation and not just a simple value. And I think that's correct, so I can go and test that now as well. And my test case says that my first test case says 10,932 kilowatt hours. And 22,629.24. Let's see if that was my test case. It is. And so I'll need to finish up with my other test cases. I'll do that with the recording turned off. Everything is looking good. Again, my building formula is very simplified. It's not a very impressive solution to just do the simple multiplication. But everything works according to what the problem specifies. The only thing left is a demonstration of polymorphism. It asks me to put put objects of each class into an array list and then iterate through and use polymorphism to call that method for each different object. Now, we haven't covered lists yet in this class, or depending on when you watch this video, we may not have covered it yet. So I'm actually going to use an array instead. And so what I'll need to do is, well, actually, before I do that, I want to explain or point out that the idea of polymorphism is going to help us a lot here, because if we wanted to have all kinds of bikes and cars and houses that we consider, if we don't have polymorphism, then we have to have an array of bikes, and we have to have a second array for cars, and we have to have a third array for houses, and we have to write all the same code for all three of those different arrays. What polymorphism allows us to do is have an array of iCarbon footprint references. And into that array, we can put references for any object that implements that interface. And then we can have one array, we can loop through it one time and handle all of them, whether they are cars, bicycles, or buildings. So that's what we want to do here. I'm going to first create my array, and the type for this array is going to be iCarbon footprint. I'll just call it footprints, kind of a weird word, but and I'll instantiate that. And I only need to hold 3. It said I need to demonstrate one of each type, and you're going to see I'm just going to kind of modify the code that I already have. And what I'll do now is I'll kind of manually assign one of these references to each of my array elements. So I'm going to say footprints 0. I'll do the bicycle first. And like I said, I'm just going to steal my own code here. Then I'll take the car. And then I will take the building. And then I want to do what I call a traversal, just a loop that goes through the array. I'll use a for each loop. They're easy, and I don't often use them in videos, so it's good to throw one in every once in a while. For each I'll get rid of that label because I don't know if it's going to be a bicycle or a car or whatever. And I'll clean up my excess code here. So what this is going to do is it's going to traverse the array. At each spot, I is going to be a reference to the current object. It's going to look at that object, and it's going to, because of dynamic binding, it's going to realize that it can call get carbon footprint on any reference, no matter what subtype it is or what implemented class it is. So let's test that and see how it works. And that is what I expect to see. So I could use this as another way to run all of my test cases as well, right? I could make the array a little bigger, have room for 1 bicycle, 3 cars, and 3 buildings, and I could put all of my test cases in it, and I could run it all through at once. And I think that's where I will leave this video. If you have any questions, please just contact me.